All right, so today I'm going to talk about WebSockets and specifically the socket.io library. Does anyone here know what WebSockets are? Yes, one person? Okay, that's good. That's what you're here for, right? To learn. So a few weeks ago, we built a chat application. And the way that chat application worked is that every 2 seconds, the chat application would ask the server, do you have any messages? And then the server would say, no. After 2 seconds, it asks again, hey, do you have any messages? And the server would say, no. Then another 2 seconds, it would say, hey, do you have any messages? And the server could send you a message, say, yes, my new message is LOL, lol. So I guess as you can all see here, this is not really efficient because we're always communicating back and forth with the server. And most of this communication is useless. We don't have many messages. So what WebSockets does is that it changes the way communication happens on the web. So instead of the client saying, do you have any messages? The server would tell the client, hey, I have a new message. I love you. And then if you want to send a message, the client just says, I don't love you. So there isn't any polling back and forth, but the client tells the server, hey, I'm here. You could tell me whenever you get any new messages. And the server would send all the messages directly to you. So the way this is possible is using HTTP 1.1. So how does HTTP 1.1 make it possible? HTTP 1.1 introduced 3 key features, which I like to call the 3 Ps. So the first feature is parallel, which means that you could request multiple resources at a time. So when you open the browser, you don't have to wait for the first image to load before going and asking for the other image on the server. The second one is pipelining, which is very close to parallel, but what it means is that you could have one connection open and request multiple files on it. So with HTTP 1.0, you had to open a connection, download the file, close the connection, then open another connection. And opening and closing a connection actually takes some time. It has to make 3 trips back to the server, back and forth. So with HTTP 1.1, we only do it once for one server, and we get all the files we want. So last but not least, the most important thing for WebSockets and real-time communication is persistence. So with HTTP 1.1, connections are persistent. What this means is that once I connect to a server, even though I downloaded all the files, the connection by default is still open. So if I wanted to send any message to the server or the server wants to send something while I'm on the page, it can easily do that without having to establish a new connection. So this is from the protocol side, but then we don't code HTTP, right? We code JavaScript. So how do we access these features using JavaScript? So what they came up with is something called WebSockets, which is a JavaScript API for doing just that. Lets us communicate using the HTTP 1.1 features. If you look at the documentation for WebSockets, it's pretty simple. It says it's an advanced technology for opening an interactive session. And if you click on it, you would see it has some attributes you can use, like an onMessage, onError, onClose, similar to what we've been doing with jQuery. Honestly, I've never really used WebSockets. I always use a different library to do that. And the reason is that if you look here, WebSockets is not supported by many browsers. If we look at the mobile browsers, it's actually not supported by any of the browsers yet. So if you use WebSockets and you build your app natively using that, you have a high chance that it will break on some devices. So the issues with WebSockets is, first, it's really low level for our app. So there is only one way to send messages and receive messages, and everything is done through callbacks. So we'd have to have our own mechanism of actually adding meaning to the messages. Like, hey, this message is for receiving a chat message, and this is for sending a chat message. The second one, which I just talked about, is that it's not widely supported. And the third reason is that it's still immature. So in the coming few weeks or month, we could imagine the API might completely change, and this would mess up all the apps we have. So if we wanted to utilize that without actually using it, what can we do? We can use a wrapper library. And the most popular is socket.io. So can you guess what the URL of the website is? Socket.io. So they named it because of the website. And oh yeah, fun fact. So Socket.io started a new project called Engine.io, which is like the bare bones of Socket.io without some of the features. But they could not buy the Engine.io domain name. So when you go to Engine.io, it takes you to a different website. So the only way to see Engine.io is to go to Socket.io and look for it. But okay, that's not important. So this is the website for Socket.io, and it's pretty simple. I'm not going to go through the website, but we're going to see the code of how it works and how we could use it to add real-time communication to our apps. So what are the benefits of Socket.io? Why do we want to use that? So I'll say one thing is that it's event-driven. So what? Did you ask a question? Oh, sorry. Yeah, the first thing is that it's event-driven, which means that we could, the same way we use JavaScript events to like handle buttons and on-clicks and downloading files, we could use it exactly to send real-time messages to the server. So it integrates well with our development environment. The second thing is that Socket.io gives us code that runs on the client and on the server. So on the server, we run it using Node.js, and on the client, it runs in the browser. So this way, we could literally copy code from one place and put it in the other place, and then it would run over there and works as we expected. And the last thing which I just talked about earlier is it has fallbacks for other platforms. So if something doesn't support WebSockets, Socket.io would like use polling or anything in the backend until the other browsers mature enough to have WebSockets. And then you'll be able to utilize this technology. So before I start showing you how Socket.io works, I'm going to show you a real-world example, which is what we'll be talking about. Let me open this. Okay, so I want everyone to go to this URL that I have here. And you should see the same screen that I'm seeing. And once you get there, you could click on that and actually draw something. And it would show up on all of our screens at the same time, in real time. Okay, I started seeing some drawing. I only tested it with 2 users, so I have no idea how it's gonna work with that many users. Okay, it's decent. Let me try to clean this up.
Why is there an X? You got tomatoes, man.
Okay, so this is awesome, right? And the way we could do this is actually using Socket.io. So what happens is that whenever any one of you clicks, whenever any one of you clicks on the drawing board, we would be sending data to the server, and the server is broadcasting it to all of us in real time so that we could render it on each of our browsers. So enough of the show, and let's look at what the code looks like. So I'm gonna, yeah. So I'm not gonna do like we always did. I'm not gonna live code all of this in front of you, but I'm gonna show like first what the features or where Socket.io is used, and then I'm gonna show you how it integrates with the rest of the app. So the client side works with the server side. I have no idea how to make this larger. Whoops. Okay, so before we look at the client code, let's look at the server code for doing this. And it's really simple. It actually fits on this screen. So what we do is first we initialize an Express app like we always did. And we use a Node.js HTTP server. And then Socket.io actually hooks up to the HTTP server, just like our routes hook up to the Express.js middleware. So if you don't get what Express.js or all of this is, don't worry. It's not that important because we're not using it here. What you have to focus on is I/O. And this is what we will be using to access the Socket.io interface. And what we have here is that we have 3 arrays, one called clickX, one called clickY, and one called clickDrag. So whenever you click anywhere on the screen, you are sending coordinates that will be appended to these 2 arrays, clickX and clickY. ClickDrag is a little more complicated. I will get to it once we start looking at the client-side code. So basically what we define here, we say io.sockets.onConnection. What this means is once any of your browsers opens the web page, this function is going to be called, and we will get a socket, which is just an object that lets us communicate with the client. And in Socket.io, there are only 2 functions that you need to know, and then you could do just what you just saw here. The first function is called emit, and what this would do is you get a socket and you say emit, and then it's gonna send an event to the client side. So when we say emit initialize canvas, it's gonna send this event on the client side and add all of this data to it. So let's look at what the client side looks like. On the client side, we have socket.on init canvas and function that accepts data. So basically, when you say emit on the server, on gets called on the client. And it's both JavaScript. You feel like it's only one code base. So let's see what the server does. Whenever we initialize the canvas, we're sending all of the clickX and clickY and clickDrag data that's on the server. So basically, these arrays are collecting what all of you have done. And whenever someone connects opens a web browser and goes to the URL, the server is going to send him all the data it has so that you could draw everything on your screen. The next thing we do an on the server. So emit would send this to the client, and on would listen to client events. And as you could expect, the event is called addClick, which is when you click and move your cursor, you would always be sending this addClick event with a data.x, data.y, and data.dragging. And after we get this event, we would say socket.broadcast. So socket is the person who sent this event. So if Titus actually drew something, socket would be Titus. And when we say broadcast, socket.io would send it to all of the people who are connected to the server except him. And then we say emit. And I'm emitting a draw event, which the client side would have a callback for it, an on event that would draw whatever he drew on the screen. So that's all the server needs. We just get events, broadcast it. That's it. Does anyone have any questions on the server? Yes, Joshua?
How does it know not to broadcast the Titus?
So the socket that's passing this callback is actually Titus's socket. So when we say socket.broadcast, what Socket.io would do is, hey, this person is broadcasting a message to everyone, so we don't need to send it back to him. Okay, so enough of the server code. Let's look at the client.
So
Yeah.
if I had something where there are certain sessions that, like, I have multiple sessions in my site where a group of friends in each session are going to be doing their own drawings. If I say emit, will that emit it to every single?
Yes.
Is there a way to scope that?
That's a really good question, and Socket.io has something called rooms. So instead of Socket.broadcast, you could, actually maybe it's called channels. But basically you could create a group of sockets and put them together. So see, whenever you have a connection event, you could actually subscribe a socket to one of these rooms, and then you just get the room and say .broadcast, and it's going to send it to everyone in that room, not everyone connected to the server.
So the socket that is living in the browser has like some sort of session key that it's generating and maintaining.
Actually, the socket so when the browser is connected, the server would create a socket and would send, like, the server knows on which connection room the browser is in, but the browser doesn't. So if you want to implement room functionality, you would have to let the browser kind of know that it's in a certain room.
Okay.
But it would only receive the data that it's supposed to receive from the server. Does this answer your question? Cool. So let's look at the client code. So basically, this is the client code, and the things that I want to focus on right now. All of this is just JavaScript stuff that has nothing to do with Socket.io. The Socket.io that I'm using is based only this and these two functions right here. So let's look at what this does. So I had an add click function that says record a pixel, and what it does. So on the client, I have a click X, click Y, and click drag arrays, just like the server. And on the server, I have the same arrays. And the reason I do that is if I don't save them on the client and you draw something, it would not show up on your screen until the server sends it back to you. But if you draw it locally, then drawing on your screen is going to be fast, so you won't feel that it's slowing down. But while on the other people's screen, it might be like half a second later than it shows on your screen. So it's only to make it feel faster as you're using it. And I had this if condition, and I'll talk about the from server later on, but let's look at socket. So what socket means is if socket.io actually connected to the server, then socket would be defined. And this is where it's defined. I would say socket equal io.connect and give it the URL of the server. And then it will be defined. So I'm going to emit the coordinates of the cursor so that the server would send it to everyone else. The from server is a very interesting bug. So I did not have this parameter before. But basically what happened in this add click function was when one of you guys drew something on the screen, I use the same add pixel function that I use when I draw on the screen. So if you draw on the screen and the server tells me, okay, you should add these pixels, my browser would add it, and then it would execute this again. So you're going to draw it, it's going to come to my browser, it's going to send it back to the server, and I'm going to draw the same pixel. And you get into an endless loop that crashes the browser. So basically, I had this boolean that I would set to true when the server. Wait, I would set. Oh wait, that's not it. Yeah, here. I would set to true whenever I receive an event on the server, but it's gonna be false when I draw on my screen, so that when something comes from the server, I won't echo it back and like crash all the clients connected.
Okay, so stuff like that obviously makes testing sockets difficult, right? Because I mean, that means you're going to have several clients to work with if you're testing, right?
Right.
Yeah. So is there like any way to just like simulate that without actually having them? Multiple. Like
so
you have to have several people, several browsers.
Yeah. So what I had is I guess. Yeah, so when I first tested it, I had two browsers on the same screen, split screen, and I try once here and try another time here. But that's not good enough because I had a bug when like any person is drawing at a time, it would work. But when both of them are drawing at the same time, weird things happen. So you need another computer, or you need someone else to help you test it.
Do you know of any like strategies that you would have for load testing with sort of like sockets? Like besides just having like a huge list of people who could just do it.
There are some automated tools. I'm not sure if there are anything specific for WebSockets. But yeah, I'm sure you could find something. Okay, so basically I guess that's it for Socket.io. All we do is send events whenever we draw something, and then the server broadcasts it to everyone else, and we render it on our screens. So do you guys want to see how the client side works, or is that not important to you? Yes, no? What?
You're the boss, man.
You're the boss. What do you think would help us?
Okay, so I'm going to show you how the client side works. At the beginning, I start by defining the three arrays that I had here. I had a paint variable boolean, which is either true or false. A canvas, so this is an HTML element that lets me draw things with a brush on, and this is exactly what you see on the screen. And I set the width and height of the canvas to 600 pixels. And then I have these events that I define here. So on mouse down, so when I click my key, what I do is I get a mouse X. Now e.pageX would give me the coordinate, the absolute coordinate of the mouse on the web page. So let's see an example. If I click here, it could give me something like 1010. And if I click here, it could be something like maybe 200, 500. But actually what I want is I don't want the distance from here. I want the distance from this box to be able to draw. So what the difference does is that, let me go back here and hope it doesn't crash. Okay. No, I think I turned it down. So what my function does is it only takes the difference between this origin and this origin, so that the coordinates are with respect to this. Okay. Okay, so did you all see what just happened? Okay, so I actually lied to you.
What a jokester.
Yeah. So the code that you just saw here was not the same code for the application that was running when we first started. And the reason was there was a very bad bug that I spent 2 hours trying to fix. And it's what you just saw right now. When I click somewhere and someone clicks somewhere, right now, what the server has is... Okay, actually, I'm not sure if I should start with this now. But okay, I'll try to do it quick. What a server has, it has a click X, click Y, and click drag. But it doesn't know which person actually did the click. So when I click on the left and move my arrow, and you click on the right and move your arrow, what it thinks is that I went all the way back and forth, back and forth, back and forth. And that's why this entire screen became solid orange. I'll show you how I fixed it later on, but let's go quickly on how the client side works. So yeah, here I get the mouse X, mouse Y, set paint to true, which means, hey, I have a pen and I stuck it on the paper. And then I add the click and I redraw the screen. Now whenever I do mouse move, I know that paint is true, which means my pen is still on the paper and I'm just moving it, so I have to draw. Well, you know, if you're just moving the mouse without clicking something, it's as if you had your pen off the paper and you're moving it, so we don't want to draw anything. So that's what the paint boolean is for. Is this clear? Yeah. Okay, so yeah, mouse move, if paint is true, then we do the same thing as mouse down. We just get the coordinates, send the click to the server, and redraw the screen. Mouse up would set paint to false, which means that we're actually taking the pen off the sheet. And the same thing for mouse leave. When the mouse leaves the canvas and you go back on, it's going to stop drawing. we just looked at how add click works. Redraw is pretty simple. So the first thing we do is we clear everything on the screen, which is usually used for animation. This is why it, like, you could see how people are moving their pens instead of them just appearing. And then we say context at stroke style. This is the color that we're using. Line join round. This means instead of drawing pixels, you're gonna draw circles, and the radius of, or maybe the diameter of the circle will be 5 pixels, so it looks smoother. And then what I do is I go through all the coordinates and I begin a path. And basically what click drag does is it senses whether the paint was on or off when the click happened, and it lets us like draw different lines at the same time. So if we couldn't tell, if we had the coordinates but we don't know whether the pen was released or not, then we'd be drawing in places where we shouldn't be drawing. But since we have this, what we would do is we always use line 2, and whenever like the person moves the cursor away and starts drawing again, we move the context again. So basically what this does is it like puts the pen somewhere, then moves it and draws using it, and finally closes the path and paints it. Yeah, this is not as complicated as it looks like. Once you see the API and see examples, you'll probably get how it works. And basically that's all of it. This is how the collaborative canvas works. Any questions before I show you how I fixed that bug? No? Okay, let me try to demonstrate the bug again. Jackson, can you just draw a line with me?
I'd be privileged.
Okay. I'm going to draw a line on this side and you draw it on this side.
Yeah, to the website.
Okay. Okay, I want you to simultaneously draw a line here. That's 1, 2, 3.
The other side.
Oh. Okay, I think it crashed. Okay, I'm gonna restart it.
Should I reload?
No, you should.
It's hanging for me.
Okay, I guess because we have so many people here, it's not, it couldn't handle it. But basically what happens is if someone draws on this side, another person draws on this side simultaneously, we would see lines going this way. So,
I'm good at this.
okay. Okay, this means that people were drawing like very close. Can I show it to everyone? So yeah, this is what Jackson got. And the way this happened is someone was drawing on this side and someone was drawing on that side. And then the server the client connected all of them because it thought it was the same person going back and forth. Yes, I'll go quickly over how I fixed it, since it's a little messy. Okay, if you saw what happened here, I added one array called click user, which gets the ID. So socket.io by default assigns an ID to every user who's connected. And you can access it using socket.id. And whenever I emit a draw event or any event, I actually send the user with it. So I know, hey, this is Jackson and this is Saleh. They did draw like different. It's a way to differentiate which user drew which line so that the client can render it. On the client, the code doesn't look as neat, but instead of having 3 arrays, I'm actually not using these anymore. I had one object that has an ID for every user. Then every user has these 3 arrays: click X, click Y, click drag. And then when I render them, I render it one user at a time so that it doesn't mess up by connecting the drawings of different users together. So yeah, that was basically it. I think we finished early. Do you guys have any questions or anything you're interested in learning about?
That's really good.